Hello again. So we're going to look at estimating the answer to a question. Before we do that, I want to look at why we estimate the answer to something. So there's a number of reasons that we use estimation. One reason is to get a feel for a quantity. So for example, we've got here a classroom, a plan of a classroom. So if you imagine that's looking down on the class, we have got a length of 5.91 meters and we've got a depth of 4.02 meters. Why would we use estimation? Well, one reason could be as simple as trying to get an approximate quantity for carpet. So you might have someone that's coming in to estimate the area of this carpet. So then they can price that carpet up. It's a lot quicker than working out the exact dimensions and then going back to work things out later on, when all you want to do is get a feel for quantities. So there's one reason. The other reason is to check if you've actually got something roughly correct. So let's have a look at this question here. We're going to estimate the area of this classroom. So we've been told, or we know, that the length of the classroom is 5.91 meters and the width of the classroom is 4.02 meters. Now if we do that exactly, and we do that in our calculator, we will get 23.8 meters squared to one decimal place. So let's look at estimating this. If we're going to estimate this, we don't use these full numbers. What we do is we change these to the nearest one significant figure, and then we can do that calculation in our head. So 5.9 to one significant figure would be 6. I'm going to multiply that by 4.02 to one significant figure would be 4. And 6 times 4 is 24. Now we don't put equals here. The estimation is not an exact answer. What we do is we put approximately equal to, like a squiggly equal sign, approximately equal to 24 meters squared. Right, let's have a go at a few. So we're going to work out an estimate for each of these questions. So again, each time, what we're going to do is we're not going to get the exact answer. We're going to change them to one significant figure. So that's the key thing to remember. Change everything to one significant figure. So this question here, we are going to do, well, 5.7 is near 6, 31 is 30, 6 times 3 is 18, and then we're timesing it by 10, which gives us 180. Just so you know, the exact answer for that one there was 177.3 to one decimal place. So you can see these two are really quite close. They're in the ballpark figure of around about 200. And we must be careful not to get hung up on differences too much. It's in the region of 150 to 200. It's in the region of 150 to 200. If we look at this next one, I would write this slightly differently. Well, 42.5 rounds to 40 and 4.83 will go to 5. Notice I've put it over. I sometimes think that's an easier way of showing it. That is approximately equal to, well, 5 goes into 48 times. Let's see what the actual answer is. Well, the actual answer will be 8.8 to one decimal place. So again, we're very close. Looking at this next one, 231 squared. This is where people get a little bit kind of worried about going away from rounding to one significant figure. Some people will do 230 squared. Well, that's still quite a difficult thing to do. Don't. Just stick with the one significant figure. Go for 200 squared. Well, you know 200 squared is just 200 multiplied by 200. So in this case, we can go 2 times 2 is 4, and then we're multiplying by 10, 10 again, 10, and 10 again. So 2 times 2 is 4, 40, 400, 4,000, 40,000. Another way of looking at that is 2 times 2 is 4 with 1, 2, 3, 4 zeros. There you go. So the actual answer to that one is just over 53,000. Now that may seem like a huge difference, but let's think about this carefully. We are looking in the tens of thousands. So yes, it is in the tens of thousands. So it gives us a feel for the quantity. Again, don't get hung up on it not being exactly close. That's the point of this. It's an estimation. It's an approximation. Let's move forward and see whether we've got an underestimation or an overestimation and how we recognize that. On this first question here, we rounded up for the first number. However, we rounded down for the second number. So it's difficult to see whether that's an underestimation or overestimation. And as you can see, it is very close. So this next one, 42.5, we rounded down. 4.8, we rounded up. And again, that kind of balances itself out. So difficult to see if it's an over or an under. So that's given us a very close answer. However, if we look at C, we have rounded down. So we have rounded the 200 and the 200 down. I think it's clear to say that we will have an underestimation here. And you can see we are below the actual answer. So yes, that is an underestimation. So that one's easy to tell. These ones not so much. Okay, looking at these questions here. So we have got 4 multiplied by 500 divided by 0.4, all to one significant figure. That is around about, well, 4 times 5 is 20. That's times in by 2 lots of 10 again gives me 2,000. Divided by 0.4. I don't want to divide by a decimal, so therefore I multiply numerator and denominator by 10. So now I've got 20,000 over 4. Well, 20 divided by 4 is 5, and we've got 3 extra zeros, so that is 5,000. So next question, we are looking at rounding that to 30 cubed. So that is approximately 30 by 30 by 30. 3 times 3 times 3 is 27, multiplied by 10 by 10 by 10 gives me 27,000. And finally, we are going to estimate the volume of this cuboid. So with these sides here, so our first side will be rounded to 30, our next side will be rounded to 40, and finally our longest side will be rounded to 100, not 120. And so if we do this, we have 3 times 4 times 1, which is 12. We have 1, 2, 3, 4 zeros after that. So that's 120 centimeters cubed. So now we need to look at all of these questions to decide whether something's an underestimate or an overestimate. We have rounded up here, but we have rounded down here. And that's quite an insignificant round. So this is a difficult one to decide if it's rounded up or down. We get an answer of 5,000. The actual answer was 5,790.5 to one decimal place. So you can see it's very close. Our estimation is an underestimation. This one's a little bit easier to see. We've rounded that up and we're multiplying in our rounding. So we've compounded that rounding error. That is definitely an overestimation. So the answer to that actually was 21,484.9 to one decimal place. And you can see it's an overestimation. That's okay, by the way. There will be over and underestimations. They're not meant to be exact. And finally, we rounded that one up. We rounded that one up. Now we're multiplying those two rounding errors up, but we rounded that one down. So I would suggest, because we're compounding the rounding here, I would suggest that is a very slight overestimation, because that's quite a large underestimation. Let's see what the answer is. So that would have been 119,751.3. So as I said, it was a very slight underestimation. Right, so I hope you get a good feel into estimating the answer to questions, so finding approximate answers. And as always, if you've got something from this, please like and subscribe.